Hello everyone and welcome to an episode of Interstigation. Even though in the last video I promised that we will be going over number 15 on the Amy today, but I want to talk about one that's very popular right now, that as it is happening right now at the biggest sporting event, even more popular than the Olympics. Only happens once every 4 years, so I will use this opportunity to introduce a math concept behind it. Obviously, there are a lot of prediction videos about the World Cup, but that says, how many teams are going to get to the quarterfinals? Who are they? Who has the most highest chance of winning this World Cup? While that has a lot of mathematical knowledge to it, it is really hard to say, and there's only one reality, one winning team. You can't run this experiment. You can't run the World Cup 1,000 times or even 1,000,000 times. Let's say Brazil wins the World Cup 14% of the times, so Brazil is given the champion. There are humans playing these games. They can't play, let's say, 1,000,000 matches in just a month. So there's only one outcome, and in these tournament style competitions, there are going to be a lot of upsets, as we've seen today from Morocco beating Spain on penalties. But I want to talk about another aspect of this, and more like the rules aspect of the World Cup, specifically the elimination rules. So, as you all know, there are 8 groups in the World Cup, and the top 2 groups from each the top 2 teams from each group gets promoted or qualifies to the next round, also known as the elimination round. 2 of the teams will face off against each other in such a bracket such that the loser immediately loses and goes home. But the winner goes on to the next round until we get to the final match. Let's just ignore the third place match for now, and we can ignore the group matches for now. I want to go over a concept that helps you memorize and derive the formula for the sum of geometric series. I have already done a video on infinite geometric series using Zeno's paradox, and if you haven't watched that, please go ahead and pause this video, go watch the other one. The other one is just as interesting as this one. So in the other one, we concluded that if 0 is less than r is less than 1, we have the sum a plus ar plus ar squared all the way to infinity. I have infinite terms is equal to a over 1 minus r. Now we want to look at the case where r is possibly greater than 1 and how that affects things. We will not yet consider where r's are negative, but that is also rather a semi-easy thing to extend upon this lesson. So let's get started. Let's first of all use the actual World Cup as an example. If we have 16 teams in the beginning, and we want to find one winner from elimination, and that elimination is going to be whoever loses just goes out immediately, which means that the bracket will look like this. And as long as the bracket looks like this, we can count how many total matches are there. we counted that there are 16 teams, but how many total matches do we actually need to find that winner? So there's one final match. Let's just count it. And for semifinals, there are 2. Because there is one here on the left-hand side, there's one here on the right-hand side. For quarterfinals, there are 4 matches on each of the quadrants. And there is another round of 16 that has 8 matches. So we can represent the number of matches as 1 plus 2 plus 4 plus 8. That obviously is 15, but we don't really care about the result. We just care about what we can write it as. Now, let's think about it this way. If we have 16 teams and 1 winner, and each match eliminates 1 team, because we don't know how many matches each team will play, but whenever a match happens, 1 team gets eliminated. They can no longer participate in the World Cup. So each match eliminates 1 team. That means for us to eliminate 15 teams, we need 15 matches. So that matches, the number of matches with our number of matches, calculated in 2 ways. So now let's extend this a little bit. Let's say now we have 2 to the n teams and 1 winner using elimination. How many matches would I need? It would have shouted out immediately, that's 2 to the n minus 1, right? We want to eliminate 2 to the n teams and just leave 1 there. So we want 2 to the n minus 1. What is that equal to? That is equal to 1 plus 2 plus 4 plus 8 plus 2 to the n minus 1. The last round, the outside round, is going to be all 2 to the n teams are going to participate, and 2 teams are going to be in the same match. So in the last round, there are going to be 2 to the n minus 1 matches. So we get this interesting result. Now, how do we extend this result even further for us to generalize it to any geometric series? So we can take a look at here. Now, maybe if we don't have 2 to the n teams, let's consider a case where we have 3 to the n teams, and we want 1 team left. But this time, in each of the matches, 3 teams play 1 match together. And we would have that 2 gets eliminated. You might not see the left-hand side immediately, but we can tackle the right-hand side. The last one is going to be 3 teams playing 1 final match to find the winner. And then we have 3 matches on each of the 3, I guess, sections. It's going to look quite weird. It's going to look like this of some sort. Now, that is going to be 1 plus 3 plus 9 plus ... And this last one is going to be 3 to the n minus 1 matches. And this left-hand side, let's think about it. We want 3 to the n teams minus 1, that many teams to be eliminated, which means that we want that many teams to be eliminated, and each match can eliminate 2 teams, which means that we just divide that by 2. Now, let's take a look at this result. It's very interesting, isn't it? So if we can do it with 2, we can do it with 3. Why can't we just do it with any number r? R to the n teams. No one says, oh, I have to have a whole number of teams, right? We could have 2.7 teams in a match, and we want to eliminate 1.6 teams per match. And we want to have 1 team at the end. So now, 3 teams, or not 3 teams, our teams play a match. And we would have r minus 1 getting eliminated. So now, this right-hand side is just going to be 1 plus r plus r squared plus dot 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 plus all the way to r to the n minus 1. Even if it's not integer, it works because no one says we cannot have an integer number of teams, right? And the left-hand side is going to be r to the n minus 1 over, that is, right, r minus 1, because r minus 1 gets eliminated every time. Okay, this is a looking good formula, but how about let's just not leave with 1 team? What if we want to have a times r to the n teams total, and a teams win? Now we have r teams play a match, and r minus 1 gets eliminated. So now, how do we care about this? There's a times r to the n teams, and we want to subtract a because though a teams should not get eliminated, and each round we can eliminate r minus 1 teams. And for the last round, there's going just to be 1 match. That 1 match, the last round is going to be A matches. And that A matches are going to be basically happening in their own separate brackets. And each of those brackets are going to have 1 winner to it. So if we have a total of 8 A brackets, then a total of 8 brackets. That is horrible drawing, but you get the point. If we have A brackets, then at the end we will get 8 winners. So it will be A plus times A brackets, and in each bracket the number of matches will just be A plus 1 plus r squared plus r to the n minus plus dot 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 plus r to the n minus 1, just like the one above. Now we're just duplicating the World Cup. We play the World Cup A times with different teams. Now, let's see what result we actually got from this. We got, if we expand the right-hand side, a plus ar squared plus dot 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 plus r to the n, or a times r to the n minus 1 is equal to a times r to the n minus 1 over r minus 1. And that is exactly what the sum of a geometric series is if we add from a to a times r to the n minus 1. And notice that there are exactly n terms over here. N rounds, I guess you should say, within the context. And the reason I did not change this to n and this will be n plus 1 and ish is because this nice n terms over here. Not thinking about the highest power, but thinking about how many terms there are. But let's go back to our original equation that I provided in that Zeno's paradox video as well. How can we know this? All right, can we deduce that formula that we had over there in order to get this formula over here? Let me see if I can copy this. Let's just copy and paste it to the bottom. Let's compare these two formulas. So the only thing that it looks different would be this 1 minus r, and this 1 minus r, and this r to the n minus 1 does not exist. So if you know a little bit of calculus, even a little bit, just limits, if we take that limit as n approaches infinity of a plus ar squared plus all the way to ar n minus 1. Even if you don't know calculus, stick around because I am going to explain intuitively why this is true. That is equal to the limit as n approaches infinity, just means as n grows larger and larger and larger of a times r to the n minus 1, r minus 1. Reminder here that r is between 0 and 1. And because r is between 0 and 1, if we have a number between 0 and 1, multiply it to itself, no matter how big it is, 0.999999 squared, cubed, 4th power, 5th power, 6th power, eventually you are going to get a number n big enough such that this r to the n approaches 0. This means that this is equal to the limit as n approaches infinity. Well, it's not really a limit anymore because n does not exist anymore in this expression. So it's a times 0 minus 1 over r minus 1. And this inside is negative 1. We can put that in the denominator, which exactly gives us a over 1 minus r. So from two very drastically different scenarios, one is what we have known as the Zeno's paradox, and the other in the scenario of World Cup elimination stage, we indeed get the same formula as a result. And you can use this formula as basically anything as geometric series. This formula helps a ton. But with that being said, that is it for what I have prepared for you today. As always, enjoy the World Cup while it lasts, and whoever wins, they win. Good job to them. And as promised, I will upload the number 15 video in probably a week, maybe the weekend. I have it already recorded, I just don't want to release two videos at the same time. Alright, with that being said, please have a great day. If you are still in school, please good luck on your finals, and I will see you in the next video. Goodbye.